Next up, when it comes to sugars, well, what can happen to them? Now, one example of a derivative of a sugar is this molecule right here, N-acetylglucosamine. So if we take that name, acetylglucosamine, we have at its heart glucose. Carbon number 2, 3, and 4 follow the pattern of hydroxide groups going downward. So down, up, down. That's our pattern. Down, up, down for 2, 3, and 4. Now, carbon number 2, rather than having a hydroxide group there or an alcohol group there, we have an amino group. Now, that amino group has been acetylated, meaning we added basically an acetyl group to it. Yeah. Did I say? Yeah, it's been acetylated. An acetyl group was added to that nitrogen. So what we have is acetylglucosamine at carbon number 2 is where we have our modification. So this is an example of an amination. Any one of these hydroxide groups is possibly a target for an amination. And then once that amination has taken place, well, then you could add something more to it. You could add 2 carbons in the form of an acetyl group. You could add 6 carbons in the form of an even longer alkyl chain. In addition to that, one other common thing that's done to sugars that happens to sugars, let me rephrase, is if we look over here on the right-hand side, we've got glucouronic acid, galactouronic acid, manouronic acid. So what I want you to notice about these is that all of these are aldoses. But what makes them different is what makes them acids is that carbon number 6, that is where we've seen a modification. Carbon number 1 might seem a little bit like, oh, wait, that's different. Maybe that has something to do with the name. It doesn't. Because if you remember carbon number 1 in these linear sugars, that's going to indicate we're dealing with an aldehyde. Okay, so, or an aldose. Carbon number 1 says aldehyde. 2 through 5 just says what sugar we're talking about. But then number 6, we've replaced CH2OH with a carboxylic acid, giving us glucouronic acid, galactouronic acid, and manouronic acid. Okay. Last but not least is a common thing that happens to sugars is they can be reduced. So our aldehyde functional group can be converted to CH2OH. And whenever that reduction reaction takes place, we take something like glucose and make sorbitol. Sorbitol is a common sweetener or an artificial flavor or artificial sweetening agent that, well, it's going to be metabolized in a slightly different way from the way that glucose is metabolized. So these are common derivatives of sugars where we're taking one of the hydroxide groups or the aldehyde and we're making a change to it. All right, I hope that was helpful, and I'll see you in the next learning objective.